In this video, we're going to look at a very common exam question. Now, you might get the whole question in an exam, you might get half of the question in an exam, but it is very important that you understand both ways of doing this. So pause the video now and try all parts of the question. So it asks you to find the speed of the ball at the bottom of a slope using two different methods. So let's look at method one. We're going to use SUVAT and forces. So what information do we have for our SUVAT equations? Well, we have our displacement, which is 2.0 meters along the slope. Our initial velocity is 0 because it says from rest along a slope. And we know the final velocity is what we're trying to work out. And then the acceleration, we don't know, but we can work out. So why is it going to fall down the slope? Well, it's because gravity is going to be pulling it down. But what direction does gravity act? Straight down. What component of gravity makes it accelerate down the slope? It's the component that's parallel to the slope. So this component here, or it's the same as this component here. So this component here is going to be mg sine theta, where this angle here is theta and is always the same as this angle here. Now, that is the force that's pulling it down. What is acceleration? How does it relate to force? Well, it's force over mass. So therefore, it's mg sine theta over the mass. And you'll notice that the masses cancel. So therefore, it's g sine theta, or g sine 20 degrees. And then the time, we actually don't care about. Because we have this information now, and we can start to solve it. We can use this equation, v squared minus u squared is 2as, which means v equals 2as plus u squared, all square rooted. This is 0, so it becomes the square root of 2as, which is the square root of 2 times g sine theta times by 2.0 meters. So let's plug that into our calculator and find out what the answer is. 2 times 9.8 times the sine of 20 degrees times by 2 is 3.7 meters per second. So the second method that we're going to use is energy conservation. And we're going to realize that when something is falling, it starts with a store of GPE, and that transfers into kinetic energy. So we can say that the GPE lost is the kinetic energy gained. And we can write down our expressions for that. mgh lost is half mv squared gained. What do you notice immediately? The masses cancel. So we've got gh is half v squared. We can rearrange for v, and it's going to be the square root of 2gh. So it's very, very similar to this in form, where we've got acceleration and gravity, which is going to make it accelerate, and two distances. But they are subtly different. This s is the displacement along the slope, and this height is obviously the height that it falls, and that is an important difference. So let's work out what that height is. Well, we want this side here, so it's obviously going to be 2 sine 20 degrees. So h is 2 sine 20 degrees, and then we can substitute that in. So we've got the square root of 2 times 9.8 times by 2 sine 20 degrees. Now again, you will notice that these formulas now are almost identical. The only difference is that here it was g sine 30, we're resolving the force. Here we are resolving the height and the distance, but mathematically they end up being the same, because of course we're going to get the same answer, which will be 3.7 meters per second. So in an exam, if they just say find the speed, you're allowed to use either method. However, they might specifically say use one of these methods, in which case you do have to use the method, otherwise they won't give you the mark.